A stone is, I have written the problems because it takes time to simply write the problems. Okay. A stone is, write down the problem. A stone is dropped into a quiet lake. Quiet lake means the calm surface is very calm. Surface of the water is very calm. That's the quiet lake. And waves moves in circles. You know that that's called ripples. Waves moves in circles at the speed of 5 centimeter per second. What do you mean by waves moves at the rate of 5 centimeter per second? Means you can see the waves, no? It's the circles. So this is moving. This is moving at the rate of 5 centimeter per second. Means that is nothing but radius, no? That is nothing but radius. Here the stone is dropped. So this is what? Waves. And complete circle actually. So this is moving at the rate of 5 centimeter per second. Means the radius is increasing at the rate of 5 centimeter per second. That's all dr by dt. How fast the area, how fast the enclosing circle, area of the enclosing circle increases, means we have to work out increase in area dA by dt. When radius is 8 centimeter, 5 dt, look here, given quantity 5 centimeter per second means with respect to time. A simple problem. Okay, given that, write down the problem by making this quantitative video. Still, write down the problem first. Okay, video still not problem. First one. Okay, area A equals to pi r square. Now, one or two lines we can solve this problem. Area A equals to pi r square. Differentiating with respect to t, dA by dt is equals to pi outside. Here radius is variable, no? Radius is increases means r is variable. D by dt of r square. Therefore, dA by dt, I had given two homeworks. I think you got the answer for it. That day only answer is explained, problem is explained, and almost we got the answer only that day. dA by dt is equals to, it is pi into, what is the differentiation of r square? 2r raised to 2 minus 1, 2r, 2 minus 1 is 1, no? Into dr by dt, okay? R with respect to t, therefore upon dt as it is, r square means here you will take dr by dt according to the chain rule. Now it is 2 pi r into dr by dt is given. dr by dt is 8 because given that dr by dt is equal to 8 centimeters per second. Okay. Now 8 is a 16 pi dA by dt. Therefore dA by dt is equal to 16 pi r, 8 is a 16. Now substitute r. How fast the enclosing circle, how fast the area of the enclosing circle increases. Enclosing means this what? This is the circle, this is the enclosed area. Okay, that is the area. Increases when the radius is 8 centimeter. Means r is when radius, simply radius is mentioned, it is r. Increase in radius or decrease in radius means it is dr by dt or like that dr. Therefore, so when r is equals to 8 centimeter, correct? When dA by dt is 8, no, I'm sorry. dr by dt, it's wrong. dr by dt is given that it is r. R is 8, no? Okay. So with the speed of 5 centimeter per second, the wave is moving at the rate of 5 centimeter per second means it is dr by dt. dr by dt is 5. It is 10 pi r. Then when 5 into 2, when r is equal to 8 centimeter, then dA by dt is equal to 10 into pi into 80 pi centimeter square per second. 80 pi, 8 tens are 80. When mentioning the area, pi can be area, volume, etc. The answer may be in pi only, but expressing the length, breadth, etc. will not be expressed in pi. In that case, convert the take the value as pi as 3.14 and convert it into numbers. In area expression or volume expression, You can maintain the pi as it is. Okay, 85 unit is area means centimeter square because length is in centimeter. Therefore, area is two-dimensional, centimeter square or square centimeter, centimeter square. Time is given in the problem is second. Okay, per second. Unit should be written, otherwise they are taking 1 mark, especially for this particular rate measure topic. Okay. Second one, the second problem, the radius of a circle, again circle problem, is increases at the rate of 0.7 centimeter per second. So it is very simple problem. dr by dt is 0.7 centimeter per second. What is the rate of increase of its circumference? Circumference of the circle is 2 pi r. Simply 2 pi r. Oral question. Circumference, we take it as S. S is equals to circumference of the circle, length of the, what it is. This is the circumference, length of the circumference is simply called as circumference. The circumference area formula is S is equals to 2 pi r, differentiating with respect to t. ds by dt is 2 pi into d by dt of r in the variable here. And the radius circle increases, radius also increases, means radius is not constant here, radius is variable. For 2 pi into dr by dt, dr by dt 0.7, that's all. Okay, this 2 pi into 0.7. Here S is the circumference, S is equals to 2 pi r, say S is equals to 2 pi r. Then differentiating with respect to t, differentiating with respect to t, I told it is rate of change with respect to any other variable is not mentioned in the problem. You have to take it is the rate with respect to time, therefore you have to differentiate with respect to rate of change with respect to time. In that case you have to take differentiation with respect to time t. Okay, rate of change is not measured with respect to any other variable, not rate of change, how fast the variable quantity is changing with respect to some other variable is not mentioned. It is understood the rate of change is with respect to time. Therefore, differentiation is with respect to time in this topic. Okay, we mentioned how fast the area is increasing with respect to radius, then only you have to differentiate with respect to radius. Okay, differentiating with respect to time t, ds by dt, s is the circumference, s is the circumference. In the examination, we need to mention all these things because for circle, 2 pi r circumference is 2 pi r. S is equals to 2 pi r is written, we understood. ds by dt is equals to 2 pi constant differentiation of r with respect to t, dr by dt. Given that dr by dt is, look here, the radius of the circle is increasing at the rate of 0.7 centimeter per second, dr by dt is 0.7. Therefore, ds by dt is equal to 2 pi into 0.7, that's equals to 2 into 1.4 pi, you can write 1.4 into 3.14, 14 4s are 56, 14 1s are 14 plus 5 19, 1 carry, 14 3s are 52, 52 plus 1 53, 1 2 3, after 3 digits it is 3.396, 6 is dropped, let us make it as 9 as 10, 10 means 39 will become 40. Is it not? 39, 1 is increases. While leaving the high other digits unnecessary digit by rounding up, if the 5 are more than 5, previous digit is to be increased by 1 more. Okay. So it is 5.4. S means the length. Length means S is the length. It is circumference means the length. Okay. Therefore it is centimeters per 1 dimensional per second. 5.4 centimeter per second. Let us take the third problem. A balloon which is always remains spherical. So a balloon, inflated balloon means air filled balloon, is in the spherical shape. Has a variable radius. Understood. When it is under expansion mode, the radius increases, surface area increases, volume of the balloon increases. Volume is the quantity of air inside the balloon. When it is inflated, itself is the volume. everything changes. Surface area means the rubber of the balloon is made up of rubber cover. That rubber cover area increases, has a variable radius. Find the rate at which the volume is increasing. Means we have to work out dV. Read the problem. Which quantity, which one we have to work out? Which quantity we have to work out? Which rate of change of which quantity we have to work out? Identify that word. Then the problem is simple. For that particular quantity, write down the expression, formula, volume formula, area formula, surface area formula. You know that one. It is there in 10th standard or 9th standard mathematics. And anyhow, if you have forgotten, revise it. No, area of circle is pi r square, volume of the cube is x cube, everything we are telling. Okay. Find the rate at which the volume is increasing. Means we have to work out dV by dt, let's say. dV upon dt, let us say. Volume is increasing with radius, means with respect to radius. Here it is not dV by dt, it is dV by dr. Is it not? Because in the problem it is clearly mentioned rate of increase of volume with respect to radius. With radius means with respect to radius. Okay. When later means here we have discussed volume and radius. Volume is coming first in the statement, radius is coming second in the statement. So the coming quantity which is coming first is formula and second is later. Not only it is general English, no? So while discussing two persons or two quantities, first one is formula, second one is later. With radius, later is 10 centimeter, second one is means radius is 10 centimeter. Volume of the spherical balloon, volume of the sphere you have to consider. If r is the radius of the sphere, what is the volume formula? 4 by 3 pi r cube. What are the volume area, surface areas are necessary in this particular topic? You are getting all these formulas while discussing the formula problems only. While discussing the problems only, you are getting almost the formulas of all geometrical figures. Okay. No need to go for 9th or 10th standard textbook. Here only you are getting what it is. Volume area formulas in the problem only. So let r be the radius, third one. Let r be the radius of the sphere. R be the radius of the sphere. R be the radius of the sphere. Volume V is equals to volume V is equals to 4 by 3 pi r cube. Volume is 3-dimensional, no? Therefore here it is r cube. 4 by 3 pi is constant, no? So differentiating with respect to r. Here differentiating with respect to, here it is underlining with radius. Okay. Increasing with radius. It means differentiation with respect to r. Otherwise it is not mentioned like that. Then it is with respect to time. Majority of the problem with respect to time. Nonetheless, it is mentioned in the problem. The increase change is with respect to radius or with respect to length, breadth is mentioned. Then only you have to differentiate with respect to that variable. Otherwise, it is differentiation with respect to time only in rate measure topic, not in other topics. Okay, other application of differentiation topic. The differentiation is with respect to the variable quantity of that particular expression. Okay. Differentiating with respect to r, radius r. Okay. Radius r. dV upon dr is equal to 4 by 3 pi into d by dr of r cube. 4 by 3 constant is taken outside. In this application of differentiation, you are not getting difficult differentiation, simple differentiation. Usually x raised to n differentiation. Okay. N into x raised to n minus 1 or r raised to n differentiation. N into r raised to n minus 1. Therefore, dV upon dr is equal to 4 by 3 pi into 3r square. R with respect to r is there, that only formula of differential coefficient, means formula of differentiation is to be taken, not into dr by dt 1 comes. Okay, because RQ with respect to R. Variable matching, therefore only differential coefficient means answer of differentiation is to be taken. 3 cancels, dV by dr is equals to 4 pi r square. It is the actually 4 pi r square is the surface area of the cube. It is equals to S actually. Yes, surface area of the cube. S is equals to 4 pi r square. Okay. Therefore, volume increases with respect to radius for a sphere always. A CET, it may be a CET question. Volume of a sphere always increases with respect to radius. Sorry, volume of a sphere with respect to radius. Say what I am telling. The rate of change of volume or rate of increase of volume with respect to radius is always equals to surface area of the sphere. Okay. Therefore, the rate of change of volume of a sphere with respect to radius is always equals to the surface area S. Okay. Therefore, when R is equals to how much given in the problem? Later is 10 centimeter. When R is equals to 10 centimeter, therefore dV upon dr is equals to 4 pi into 10 square, that's equals to 100 into 400 centimeter cube. Volume is 3 dimensional, no? Centimeter cube per second, because it is centimeter per second is mentioned. Okay. No, centimeter. I went wrong. Centimeter cube per centimeter, because with respect to radius. Radius is 10 centimeter mentioned, means length is in centimeter. Therefore, it is volume is, what is the form, unit of volume? It is 3 dimensional meter cube, or if the length is in centimeter, centimeter cube upon dr. R is radius, it is centimeter. Volume is centimeter. Radius is centimeter. Therefore, centimeter cube upon centimeter. That's equals to 400 centimeter square. Okay, 1 centimeter cancels. So that is the rate of change of volume. Therefore, volume increases. Let us conclude. Therefore, volume increases. This much is written. So that is the answer. Okay, volume increases at 400 centimeter square with respect to radius. Or even you can come. So it is not necessary for examination. Once you have written dV by dr is 400 centimeter square, ended the problem. The evaluator will understand what answer you have to get. Got it. Okay. Let us take one more. A ladder 5 centimeter in easily. Let's see the time. Another 11 minutes. I can complete one more problem. Okay. A ladder 5 centimeter long. A ladder 5 centimeter long. A good problem. Okay. A good problem. A ladder 5 centimeter long. A ladder 5 centimeter long is leaning against a wall. Is leaning against a wall. Leaning against a wall. Full stop. The bottom of the ladder is pulled along the ground. The bottom of the ladder is pulled along the ground. Pulled along the ground. Just imagine the phenomena. The bottom is pulled along the ground, away from the wall. Away from the wall. This word away from the wall is understood, not necessary. Away from the wall at the rate of 2 centimeter per second. At the rate of 2 centimeter per second. With the help of the figure, I will explain. Centimeter per second. How fast is the height on the wall is decreasing, how fast? Here comes the first time. How fast the height of the ladder decreasing. The word decreasing we got H-E-I-G-H-T. Height of the, how fast the height of the ladder on the wall. Height of the ladder on the wall is decreasing when the foot of the ladder is 4 centimeters away from the wall. And the foot of the ladder, when the foot of the ladder is 4 centimeters away from the wall. Write down the problem. A ladder 5 centimeters long. Okay, 5 centimeter ladder, very short it is, 5 meter. Okay, ladder usually in terms of meter, no foot or meters. So it will be in terms of feet or meters. Okay, 5 meter long, leaning against a wall. So it means, so here is the figure. Let's take the figure. So here is a ladder. This is the wall. Okay, wall. Let us take it as Y. Vertical one, no? Therefore, this height of the ladder as Y. This is the wall actually. This is the wall and this is the ground. Let us take height of the wall as Y and distance from the, this is the ground. Okay, distance from the wall, let us take it as X. This is the ladder. This is the ladder. We take the picture of ladder like this. Not necessary. So straight line is enough. Okay, this is the ladder. 5 meters. Okay. Now AB is the ladder. Okay, AB is the ladder. AB is 5 centimeters. Understood? I'm not getting wall and ground. Okay, let us take wall and ground. So this is the height of the ladder. This is the height of the ladder. Let us take it as Y. Okay, Y. And this is the distance between the bottom. This is the bottom of the ladder from the wall. This is the wall. No, the distance is measured always. The perpendicular distance will be measured. Distance means perpendicular distance. So not this distance. Slant distance is not taken. Okay. Here is the ladder. Here is the ground. This distance is not taken. Here is the bottom. This distance is not taken. So it is wall and the ladder. Which distance? The distance between the wall and the bottom of the ladder is this distance should be taken, not this one, not this one. Okay, these are not perpendicular distances. So this is the one perpendicular distance between the wall and the ladder. Always distance. So distance between the lines, distance between the plane in the line, etc. That perpendicular distance should be taken. That x be the perpendicular distance between the bottom of the wall and the bottom of the ladder and the wall. Okay. So actually what happens, the bottom is pulled out. Some person is pulling it out along the wall at the rate of 2 centimeters per second. Mind that one here, the rate given is 2 centimeters per second. What is that one? Dx by dt. Dx by dt is 2 centimeters per second. Okay. This is pulled out at the rate of 2 centimeters per second. Automatically the ladder should come down. No, the ladder should come down. The top of the ladder. The top of the ladder should slide along the wall and it is coming down. Means height of the ladder. Height of the ladder along the wall decreases. Therefore dy by dt is question mark. At what rate height of the ladder is decreasing is question mark. Understood? This height. Why the height? No, height of the ladder from the ground. Height of the top of the ladder from the ground. That height actually decreases as it is pulled out, it is moving up. Just imagine, it is coming down. It will be coming down. Okay, it will be coming down. Then at what rate the height of the top of the ladder is coming downwards along the wall. The question dy by dt. So at what rate? The height is decreasing. Height decreases. No, as it comes down, y decreases, height decreases. Decreases means increase or decrease means it is the rate of change. Either your percentage increases and also there is a rate of change, there is a change, and percentage decreases, then also you can say that there is a change in my percentage. Okay. Therefore, rate of change means not necessarily it is increase, maybe decrease in quantity also. Therefore, both is increase or decrease, both is denoted by dy by dx. Dy by dx means rate of change. Change means may increase in y or may be decrease in y with respect to x. Okay. But decrease is there, then the quantity is negative. Dy by dx will be negative if y decreases with respect to x. Dy by dx is a positive quantity, means y increases with x. Okay. That is the next topic, increasing and decreasing function. Okay. Whenever decrease is there, then dy by dx should be taken negative. Okay. The dy by dt or dy by dx should be taken negative. AB is the ladder. Coming to the solution that offered. AB is equals to 5 meter is the ladder. Okay. Ladder. X meter is the, let us take everything in meter only. Okay. X meter, units should be same. One is meter, one is centimeter, is wrong. X meter is the ladder. X in meter. Okay. X is the length, distance between wall and the ladder in meters. Okay, in meters. In meters, it is better to take care x in meters. Here only let us take x in meters. Is the x is in meters. Y in meters is the height of the ladder from the ground. This is the x, distance between, what is it? X meters is the distance between the wall and the bottom of the ladder. Yes, bottom of the ladder. This is the bottom of the ladder. This is the wall. This is the x. Okay, this is the x. X in meter. X in meter. Here only let us write in meter. Y in meter. Y in meters is the height of the ladder from the ground along the wall. Okay. Dy by dt is question mark. Dy by dt is question mark actually. We have to construct the equation here according to the right angle triangle. Look here, right angle triangle. Therefore, x square plus y square is equals to r square. X square plus y square is equals to 5 square. That is x square plus y square is equals to 25. Differentiating with respect to t. Here with respect to time only, because given here 2 centimeter per second. Okay. Differentiating with respect to t. Now, d by dt of x square plus d by dt of y square centimeter per second. Per second means upon time, no? Therefore, differentiation with respect to t. Y square is equal to d by dt of 25. X square differentiation 2x, but x with respect to t. Therefore, change into dx upon dt. So this dt carries as it is x square dx. So plus y square 2y, 2 into y raised to 2 minus 1. Y with respect to t, therefore dy by dt change. So this numerator variable is y, no? Therefore into dy. Dy by dt is equals to 0.